this presentation by sitting because this is more easy for a microphone and because of the camera and so on. So who I am? I'm Manfred and I'm a trainer and consultant for Angular. I'm focusing on Angular since it's beta, and I'm also part of the Google Developer Expert team, which means that I have a direct connection to the Angular core team. I've also written a book. This is the book with the most ugly cover animal, but anyway, I'm very proud of it. So let's start with a picture. Let's start with this computer here. Who knows this computer? It's an 86 Intel, a good old Intel computer, the hero of my childhood. And the nice thing about this is this turbo button. You just pressed it, and after it, the machine was twice as fast as before. Okay, the real use case for it was to make the machine slower by pushing it again to be more compatible with older versions, with the former version of this computer. But now the question arises if there is such a turnkey solution for Angular. And the answer is yes, there are some quick wins, there are some turnkey solutions to make Angular faster. For instance, you can do bundling, you could do minification or uglification, and you can put Angular into production mode. All those things make Angular faster, and all those things are done by the Angular CLI. So when you're using the CLI, you get all these things for free. But there are other things you can do to make your application faster, and this is what the contents of this presentation is about. I will talk about lazy loading and preloading. I will talk about performance with data binding with OnPush. I will talk about AOT and tree shaking, as well as caching with service workers. And in addition to that, when time permits for it, I will also show you how to leverage server-side rendering. Okay, let's start with the first topic. Let's start with lazy loading. For some reason, a good friend of mine told me that I'm very authentic when I'm talking about lazy things. I'm not sure what he meant, but I think it was some kind of compliment. Anyway, what we see here is the typical structure of an Angular application. We have this root module.
Oh, okay. Now also the microphone is on. We have this root model, we also have this feature model or several feature models, and we have one or several shared models. And normally everything is loaded at once when the application starts. And of course this isn't influencing the startup performance in a good way. And this is exactly where lazy loading comes into play. With lazy loading, we can just load the most important modules when we start the application. For instance, just the root module, perhaps some other modules. And the rest is just loaded on demand when the user clicks here or there, when the user navigates to this part of the application or to that part of the application. And obviously, this is improving the startup performance. What does it take to get started with lazy loading? We just need a special route, a route that is pointing to the module file, the file that contains our ng module, and we have to append the name of the module class. In this very case here, the name of my module file is just flight booking module, and the name of the module class is flight booking module without dashes or points. Yeah, this is everything we need to do to get started with lazy loading. Now, of course, you are wondering which route is activated when we are triggering lazy loading with the router. And the answer is every module, and so also a lazy module, can have its own routing configuration. And of course, when we are triggering lazy loading for a module, by default, its default route is activated. This is the route without a path. We can even jump to a subroute within our lazy module. Here I have a subroute with the name subroute, and to directly jump to this route we need the URL segment that is triggering lazy loading. The name of this URL segment is flight booking in our example. It is this URL segment that is using load children and that is pointing to our module in question. And here we have to append the name of the subroute. Let's have a demonstration for this. For this demonstration, I've brought a sample application. It's about booking flights. And the sample application is leveraging lazy loading. So let's put this away and let's have a look into the source code, into our app routes file. Here we see that the flight booking module is lazily loaded. We are pointing with load children to flight booking module and to the module class. And because of this, the Angular CLI is just creating an own bundle for this flight booking module, an own bundle where it puts the flight booking module into. And when we are loading our application, let's do this, we see that everything is loaded, everything but the flight booking module bundle. When you look here at the list of the loaded files, there is no flight booking loaded bundle. But when we are moving to flight booking, Angular is loading this chunk just on demand. So I think that proves that lazy loading takes happen, and of course this is improving the startup performance. Lazy loading also comes with a drawback. Lazy loading just means that we are loading the things later. We are postponing work. It doesn't mean that the work vanishes. We just do it later. And because of this, when we first click at flight booking, there is this loading indicator that shows us that we need to wait for 1 or 2 seconds until the lazy chunk has been loaded. Of course, that doesn't matter much in this case, because in this case I'm leveraging localhost, but when we have a slow data connection, this could be an issue. And this is exactly where preloading comes in. The idea behind preloading is that modules that might be needed later are loaded after the application started. And so, when the module is actually needed, it is available immediately. By this means, we get the best of both worlds. The best of preloading, the best of lazy loading, I mean, and the best of not doing lazy loading. The user sees the first screen very fast, and after that Angular starts with lazy loading all the other things, and when the user clicks on this or that menu item, then the module is available immediately. What does it take to get started with preloading? We just need to register a preloading strategy. And this preloading strategy can be registered when we are setting up the routes for the root module. Normally you are calling for root for this, you are passing in your routing configuration, and the second parameter takes this parameter object, and this object has this property preloading strategy. Here I'm going with the preload all module strategy, and as the name implies, this is preloading all the lazy modules when the application starts. Of course, you can also write your own preloading strategies that are just preloading a specific amount of modules, or perhaps just modules the current user is allowed to use. So much for lazy loading. Let's switch to the next topic. Let's talk about performance tuning with the OnPush optimization technique. And for this, I just want to start with a demonstration. Let's switch over to my application. Let's search for some flights. I hope I'm online. Yeah, that looks good. There is a validation error here. How it comes? Perhaps I'm not online. Let me double check. Oh yeah, I went offline and my validation procedure is using the server. So let's reload this. Yeah, great. So let's search for flights. And here, when we see the flight result, we also see a button delay. And this button is just delaying the first flight. This is what Lufthansa is doing all the time. When you look at the first flight, it switches from 329 to 344 to 359 to 414 and so on and so forth. Please also have a look to the other flights. You see that the other flights does not change. They just stay as they are. They stay with 514 when it comes to the second flight, or with 814 when it comes to the third flight. But you have also seen this blink effect. What is this blink effect about? I'm not showing you something about animations, but I'm using here a dirty trick to visualize the change detection of Angular. This dirty trick just makes a component blink when Angular is checking this component for changes. And you see here, even though just the first flight changes, all the flights are blinking. That means that Angular is checking all the flights over and over again without a reason. Normally that isn't an issue because Angular is very fast with this. But of course, when you have a lot of bound data, this can become an issue, especially when a lot of events arises. And because of this, we have this OnPush optimization technique. What does OnPush do? With OnPush, you can tell Angular that some components shouldn't be checked at all. So Angular is skipping, for instance, the flight card components here when it comes to checking for changes. Angular will just check those components when Angular gets notified about a change within those components. So the question arises how to notify Angular about a change, and the answer is we can do several things. For instance, we can change bound data. Data that has been bound with a property binding, data that has been bound to an input property. But it isn't as easy as it seems, because Angular is just checking whether the object reference of the bound data changed. Or to say it with an example, Angular is just checking whether the current flight is the same as the former flight, as the old flight. Angular isn't checking whether the first property changed, the second property changed, the third property changed. Angular just checks whether the object as a whole is the same or the object has been exchanged by another one. Of course, this is about performance, because checking all the properties would be too costly. You can also raise an event within the component. And a special case of this is you could also notify a bound observable within this component. And of course, you can trigger change detection manually, but I wouldn't recommend this. Don't do this at home. It isn't the fine English way to do change detection, and it may cause a lot of confusion. And most of the times there are ways to avoid this. Most of the times you can just solve your issues with the first three options. At least you should try very hard to avoid this option here. So what does it take to put a component into this OnPush mode? You just have to use this change detection property within the component decorator, and you can set it to OnPush. This is everything you need to activate OnPush on a component level. And that also shows that you can decide from component to component if you want to go with this technique or not. Here I have another example. Here we have the thing we have seen within my application. I have my flight search component. This flight search component consists of flight cards, and the flight search component is passing down the flights to the flight cards. And when the flight cards are in the OnPush optimization mode, then Angular is just checking whether the flights as a whole changed. And when this is the case, Angular is doing change detection for the card in question. Otherwise, Angular is just skipping the whole component and every child component of this component. And here we see another option to trigger change detection. We just need to bind an observable to our template. For this, we are leveraging the async pipe, and in this case, Angular is checking this very component when this observable yields a new value. So let's have a demonstration for this. Let's switch back to our application. And here I have a good message. We are lucky because I just using immutables here. That means every time I'm pressing delay, I'm just exchanging the first flight for another object that has all the data of the former flight, and of course the new date. Because of this, I can easily switch to the OnPush optimization technique here. Let's do this. I'm switching to my flight card component. I'm activating OnPush. Let's wait until the compiler has recompiled everything. The application is now reloaded. Let's search for flights. Let's press the delay button, and now we see, hooray, just the first flight, just the changed flight is checked by Angular. And of course, in this case, that doesn't bring a lot of performance, but just think about cases where you have a huge amount of bound data and where each subcomponent has several other subcomponents. Nice thing. Okay, so much for OnPush. Let's switch to the next topic. Let's talk about ahead-of-time compilation. So perhaps you know it. For a matter of fact, Angular is just compiling your HTML templates to JavaScript. Angular is doing this because of performance, because JavaScript can be easier evaluated over and over again when you compare it with the evaluation of HTML. It is just costly to evaluate HTML text-based templates over and over again. And for this compilation step, there are two approaches. You can go with just-in-time, which means that the compilation takes happen at runtime. That means when the application starts, Angular is just compiling the templates. Or you can leverage AOD, which means that the compilation takes happen during the build. In this case, you have another compilation step, and so you don't have to do this when the application starts up. And using AOD has a lot of advantages. Of course, there is a very obvious advantage. You get a better startup performance because you don't have to do all this stuff when the application starts. But there are also some not that obvious advantages. For instance, you get smaller bundles because you don't need to include the compiler into your bundles. You don't need the compiler at runtime, so the bundles need to include it. So this is a huge improvement because the compiler is a real big thing. It has about 300K, and so it has about the half of the core framework. And another thing that isn't that obvious is that tools can easier analyze the whole code, because the whole code just consists of JavaScript, and JavaScript code can very easily analyzed compared to the analysis of HTML code. And so these tools can find unused parts of your applications, and they can remove those parts from the bundles. I'm sure every one of you has applications that are not using all the parts of the included frameworks. Normally, we are just using a specific amount of the possibilities of the frameworks we have included, and because of this, removing all the other parts is a good idea. This is also called tree shaking. It's a nice metaphor for shaking a tree to make all the loose branches fall down. So when I've talked about AOT and tree shaking about a year ago, I've showed the audience how to configure the Angular compiler, how to configure AOD, how to make it work together with a build process like Webpack or something else. Nowadays, I don't need to do this, because nowadays we have the Angular CLI, and the good message is the Angular CLI is doing this for us. Who is using the Angular CLI of you? Okay, about the half. Who is using something else like Webpack or System.js? Okay. So when we are leveraging the Angular CLI, we can just do a production build. That means we are calling ng-build with --prod, and now we get all these optimizations like minification, uglification, production mode. We even get AOT and tree shaking. Behind the scenes, the CLI is using the AOT plugin for this. The AOT plugin lives within the npm package ng-tools webpack. And very soon we will get another plugin for this, which is called Angular compiler plugin. And the good message is you can use it with and even without the CLI. Those things are just Webpack plugins, so you can just plug it into your own Webpack configuration. Okay, let's have a look at a demonstration for this. In this demonstration, or for this demonstration, I have prepared my example. I have prepared it in several flavors. One flavor is using a production build, but not AOD. Let's just have a look at this version. Production and no AOD. Let's start my development server. Okay, so here we have the no AOT build. Let's go to the performance profiler of Chrome. Nowadays a browser is nearly a full development environment. We even have diagnostics features and tracing features. Let's clear the cache and let's reload the application. No, that was the wrong button. Let's clear the cache and let's reload the application. Yeah, it took us about 2 seconds to get started. A bit less than 2 seconds. Let's do this again with a warm cache. Yeah, we cut it down to about 1.5, 1.6 seconds or something. So this was the solution without AOD. And now let's do the same with AOD. Let's switch to my other compiled version of this application. And let's start the live server. Let's clear the cache and let's reload everything. Stuff goes down. Yeah, it took a bit more than 1 second after we've cleared the cache, and now let's redo it with a warm cache. Of course, it should be even faster now. Yeah, not much. One more time. Yeah. So we cut it down to about 800 or 900 milliseconds. So this is the result I also got before. So nice. So that shows that by leveraging AOD, we can just cut everything about by the half. And this is the reason why just-in-time compilation isn't allowed at Google. Everyone at Google has to use AOD there. Awesome. So please use AOD at runtime. Okay, let's talk a bit more about tree shaking. There are some challenges when it comes to tree shaking, when it comes to remove unneeded parts of the application. And the biggest challenge is that most tree shaking tools are quite conservative. That means they are just removing code when they are sure for 100%. And as a matter of fact, very often they aren't sure. And so they tend to keep the code in the bundle. They aren't removing it just to be on the safe side. One solution for this is the Angular build optimizer. The Angular build optimizer has been created by the Angular team, and it rewrites the compiled code in a way that helps to make it more tree shakeable. So it helps those tree shaking tools to find out which code is really needed and which code isn't. Currently, this feature is available via the current CLI, but it is an experimental feature, so it can change in future, and it can also have some side effects. And because of this, I'm using this new logo here. This logo has been introduced last week at Engine Mix in the States, and this logo just shows that we are dealing with hot new experimental stuff. So of course now I could show you a demonstration for using the Angular build optimizer, or I could just show you this diagram. And I think this diagram speaks for itself. I think this is quite awesome. Here I managed to cut the bundle size to the half. Please notice that here I'm using Angular Material. Angular Material is a huge component library with a lot of widgets, and most of us aren't needing all those widgets. And by the means of the bundle optimizer, of the build optimizer, this code gets more tree shakeable, and so the tree shaking tools can shake off all the unnecessary parts of Angular Material, and this is what results in this better bundle size. Nice thing. Okay, let's switch to the next topic. Let's talk about caching with service workers. What are service workers? Service workers are background tasks. Background tasks that live within the browser. You can think about service workers as about Windows services that are living within your browser, or about Linux daemons that are living within your browser. A web app installs them, and those background tasks are activated and deactivated on demand. That means they aren't stealing CPU cycles all the time, but just when needed. So how do they help with caching or even with offline scenarios? Well, a service worker can do a lot of things, and one of these things is intercepting requests. It can intercept your requests, and then it can decide how to respond to these requests. It can decide to respond using the cache, or it can decide to use the network to fetch fresh data from your web service out there. Of course, there is the same origin policy, which is very important, because otherwise it would be a real security issue. Without that, we would have an issue when the service worker from site A would have the possibility to intercept requests for the site B. With this possibility, it could just inject bad code or something like this, and this is something we don't want to have. Because a service worker is just a script you can write, you have all the freedom to create caching patterns. Caching patterns like cache only or network only, or try the cache first and then use the network, or try the network first and when the network is down, use the cache. And there are even some other caching patterns that help here. Using service workers is a bit difficult because there is this low-level API the browsers brings. But instead of this, you can use a high-level abstraction, and such an abstraction is Workbox. Workbox is a nice API that has been created by Google, and you can leverage this API to get started very easily with service workers. Saying this, the next version of Angular, Angular 5, will contain an own service worker module. It is also a high-level abstraction for service worker within the world of Angular. So here in this demonstration, I'm using Workbox, and here we see a simple example for Workbox. I'm just importing the Workbox script into my service worker, and then I'm instantiating the Workbox. After this, I'm grabbing the caching strategies. I'm grabbing network first and cache first. I could also configure them, but here I'm going just with the default configuration, and then I'm setting up routes. The first route is pointing to my web API. It is using network first, and the second route is pointing to everything else. Please note that point is the regular expression for everything, so this route is catching everything else. Also my program files, my HTML files and my JavaScript bundles and so on, and for this I'm using cache first. And please also note that this isn't a browser cache, this is a cache we can control by ourselves. Okay, let's have a demonstration for this. And for this, let me start with the last example that isn't using service workers. We have seen that this example is quite fast. When we are looking to the network tab, we see that it just needs 800 seconds and something to load. But of course, we are using localhost here. We are using 127.0.0.1. And as I have found out during my research, this is a very fast address. And for some reason, it is available all the time. Just kidding. So let's just simulate something that is called fast 3G. Let's simulate a fast mobile data connection. And as we will see here, after clearing the cache, fast to 3G isn't fast at all. This takes some time. Here we are seeing my loading indicator. I'm very proud of it. And at the end of the day, we see it took us a huge amount of time. It took us about 8 seconds to load everything, even though this is considered a fast mobile connection. So this is exactly where service worker caching comes in. And to demonstrate this, let me switch over to my service worker build. Go, okay. This is using a service worker. It has been installed by the web application. When you look at the application tab here and when you switch to service workers, you see that here is a background task, a service worker up and running. It got this nifty ID here. And we could also unregister it or debug into it, but I won't do this. I'm just switching to the network tab, and here I'm simulating for fast 3G one more time. Let's clear the cache. Let's reload the page. And we see that was quite fast, but it can be faster. Yeah, we are down to 1 second and something. In some examples it was a bit faster, but I think it shows it is a lot faster than the thing we have seen before. So That's awesome, but there is something that is more awesome. We can even go offline. We can even close our web server, and the application still works, because we are now using our in-browser cache, a caching region our service worker script can control by itself. So my smartphone is telling me that I have 10 minutes left, which is nice. We are right in time. By the way, using service workers is also a strategy, of course, for creating offline-enabled websites. It's a key technology for progressive web apps. Awesome. Okay, so let's go to the last topic for today. Let's talk about server-side rendering. And first of all, the question arises, why do we need server-side rendering? Because we have all those nifty JavaScript frameworks that are doing rendering on client side, and it gives us a good user experience. Well, it is all about pre-rendering the first page, because this will just improve the startup performance, at least the perceived startup performance. And this is very important for customer apps. Customers are impatient beasts. They are leaving your website when it loads a bit longer. There are some nice statistics. For instance, Amazon tried to delay the loading time of the page for 100 milliseconds, and they discovered that this decreases the gross amount for about 1%. And 1% of the gross amount of Amazon is a huge thing, I suppose. So this is very important for the consumer. The consumer needs to get something to look at within a very, very tiny amount of time. And here, pre-rendering the first page helps. So with Angular 4 and up, we can use this nice method here, render module factory. It is a very easy method. It just gets the module factory of your root module. The module factory is what the compiler compiles out of your module class. And then you are passing in the contents of your index HTML. You are also passing in the URL for means of routing, and then render module factory is just spinning up Angular. It is creating the first page, or the page that has been requested by this URL, and then the HTML for this page is sent to this promise here, to this then function of our promise. And here I can do almost anything with this string. I can put it into a file. This is called static pre-rendering. I could also send it down to the client. In this case, I have something that is called dynamic pre-rendering. So just think we are wrapping this method into a server process, and the server process is just creating the HTML and sending it down to the user. So as mentioned before, this is available since Angular 4. It was also available for Angular 2, but there it was a community project. Now it has been refactored and it is part of the framework itself. So let's have a demonstration for this, for pre-rendering this stuff. For this, let me go to the console. Let's go to my distribution folder, and here I have the main server bundle. Yeah, it starts up. It listens to port 8000. And now let's simulate a slow data connection. For instance, slow 3G. Let's clear the cache and let's reload this. Yeah, it lasts. And after waiting some seconds, we are seeing the word server here. So this is the answer we get from the server. And after some seconds, also the JavaScript code is loaded. The JavaScript code kicks in. The JavaScript code is instantiating and initializing Angular. Perhaps the JavaScript code is even loading the data for the first page, and then the result of rendering on the client side is shown here. Let's redo this one more time, for instance with fast 3G. We are reloading the page. We are seeing the result from the server, and after this, when the client side kicked in, we are seeing the result of the client side rendering. And this is exactly what pre-rendering on server side is about. It is just about bridging this gap between the point in time where everything arrives in the browser and the point in time where the client-side framework is ready to display something on screen. So it's about bridging some seconds, but as mentioned before, those seconds are very important for consumer apps. Of course, this all isn't a free lunch. Server-side rendering comes with some challenges. For instance, you have other conditions on server-side. You don't have a document object model. You don't can access your local storage, or you don't can access your navigation, your navigator object. And to deal with this, you can create separate services. One service implementation for the server side and one for the client side. You can also use the renderer object of Angular. It is abstracting these differences away. It is doing the right thing on client side, for instance, manipulating the DOM, and it is doing other thing on the server side, for instance, writing into a string. And a huge challenge are third-party libraries, because those libraries are very often directly manipulating the DOM. And as mentioned, you don't have a DOM at the server side, so this can be an issue. This means you should check out whether your library does support pre-rendering, server-side pre-rendering. But there is also a good message. Beginning with Angular 5, you have a server-side DOM simulation. They are trying to simulate the DOM. That is working quite well, but of course it isn't perfect. So the hope is that more libraries work with server-side rendering, but it won't provide everything the client-side DOM can do. When you want to read more about this, I have a Medium series. And this Medium series contains several articles about performance tuning for Angular. You get all these slides afterwards, and you will find this link in here. So let me come to the conclusion. I think we are very good in time. We have seen at the beginning that there are some quick wins. There are some turnkey solutions, like back in the times of the 386, where we had this turbo key. There is something like bundling, there is minification, there is the Angular production mode, and the good message about this is the Angular CLI is taking care about this for free. You can leverage lazy loading and preloading to get about better startup performance. You can leverage OnPush and immutables as well as observables to improve the data binding performance. You can go with AOT and reshaking to get a better startup performance. You've seen with AOT and reshaking, we can really reduce the startup time by a third or even by 50%. And reshaking helps you to shrink your bundles. And we can leverage caching and service workers to get a better startup performance, even when we have no data connection or a slow mobile data connection. In addition to that, as the time permitted for it, we've also seen that server-side pre-rendering is a huge thing for customer applications. It allows you to pre-render everything, and this in turn allows you to show the user something more quickly. Okay, so much for this. Here you have my contact data and the links to the downloads. Thanks for coming. Muchas gracias. Yeah, there's a question.
Why is this service work example is so much faster? The bottleneck is the network, isn't it? Until the bandwidth is not it.
Yeah. So in the service work demonstration, the problem, the issue is the network. And there I've simulated slow 3G, or I think fast 3G, at least a mobile data connection. And because of the fact the service worker is caching everything, it can just pull out my program files, my bundle of the cache. And this brings the performance improvement.
Okay, it's caching.
Yeah.
But there's no effect on the first load.
No, there is not an impact for the first load. For impacting the first load, you can do something like AOD and reshaking and so on. And for the second and the ongoing loads, you can leverage the service workers.
But the cache is used without service workers by the second load.
Yes and no. It is so that when we are using just the browser cache, we can't control it. In this case, the browser can decide what it grabs from the network and what it grabs from the server side. It would be slower when we just relate on the browser cache. When we are using service workers, we can decide when to use which partition of the cache, and my script is just using the cache all the time, and because of this, there is this gain in the startup performance.
Okay, so you can suppress 304 request to the server, where the client asked if the one changed.
Yeah. That's the reason. Are there other questions? Okay, so if you have other questions later, just come to me. I'm here at least for lunch. And thank you for coming.